All right, we are live. Hello, everyone, and welcome to the stream. Hope everybody is doing well tonight. We are going to pick up a little bit ahead of where we left off last week, actually, but not too far. And we'll get into that in just a minute here. But before we jump into things, I do want to just take a quick second and thank the supporters of our channel, starting with the elite partner, Javier Olazaran, followed by our partners, Gerbolegs Inc. and Matt Osgard. Those are the highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see here, scrolling up the screen now. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. I greatly appreciate it, and it helps me cover the cost of running this channel and thus this project, things like software licenses, hosting fees, things of that nature. So thank you all very much for that. I greatly appreciate it. It helps me out a lot. With that all being said, I would also be in error not to give a big thank you to you guys, the viewer. Whether you're joining us here live on the YouTube side or on the Twitch side, does not matter. I would not have this channel or the project without you guys. So thank you so much for being here. I really appreciate each and every one of you guys. All right. Penguin Operator, good to see you. Hope you're doing well. Okay, so as we can see on screen, we've got quite a few visual updates here. I did quite a bit of bug fixing offline. And I think that was probably the right move, right? Because it was mostly just not very visual, right? But we are reaping the benefits of those visual updates now. So I did fix the water rendering, so you see now that that's rendering correctly with all the shadow maps and all that good stuff. Including our transparency is back, our reflection, our refraction are all working, so that's good. And then we have just a couple of test tree meshes here just to test our shadows, right? And then I've also got a couple of copies of this animated mesh running, which there were some issues with running more than one of those at once, so I went ahead and fixed those issues as well. But as you can see here, they've also got two different timescales. So, it just kind of showcases how that works for each individual instance. You can run those things separately. And so here's the, the lighting only view, and then the normals view. And you can see that we've got pretty much everything worked out. Here's the cascading shadow view. And of course, here's the wireframe. So we've got all the major bugs, at least I think for now, worked out from all this stuff. There's just a few things that we actually have to sort out that I guess are kind of bugs, but they're more really to-do items. And the big one of those things is we want to basically unify what we now call static meshes and our animated meshes, which we're going to get into that in just a second. We want to unify those all to become a model, right? And so we're going to call those models with sub-meshes. And so models can have two different types, either static or animated, and that's the way that we're going to reference them going into the future. With all that being said, I've already done about half of that offline. So what we actually have here is we actually have the K models system now. So this used to be the animation system. This has been renamed to the model system, right? Because animated and non-animated models are going to go through this, and we're going to use this to essentially load both types, right? So there's that. And so there may be things here and there that I've missed in terms of the rename, but for the most part, that is what we're dealing with now. So we've got this model system, and the model system is the replacement for our animation system, meaning it only takes, it only handles our animated, what we used to call animated meshes, right? And so what we're going to do tonight is we're going to start taking all of the static mesh logic and moving it into the model system so that everything is a model. And then after that, we are going to transition the actual different sort of static mesh asset type. And we're actually going to go ahead and, I guess I can't even say deprecate that. We're really going to make it obsolete, right? We're not going to use it anymore. And everything is going to flow through the new model format, since it's kind of designed to handle that. So that's the plan for tonight. We'll see how far we get. But we are working with a clean slate here. All the changes have been pushed up for the engine to the appropriate repo. So that's basically where we're starting tonight. Vulcan Zerker, how's it going? First time chatter, welcome. Diamond, good to see you as well. Hope you're doing well. From Lake, good to see you over there on the YouTube side. Your Master 000, how's it going? And Exorismut? I don't know how to pronounce that. I probably butchered it, but hello. Welcome. I hope you're doing well as well. Okay. So we can actually get rid of, I think, this buffer. Well, let's actually look at the static mesh system really quickly. I'm not thinking that there's actually a whole lot of difference between these two in terms of how things are handled. We already have, the instance state versus the base mesh state. We actually have a lot of this stuff already handled for us. The biggest difference is going to be where the asset comes from. And so I think what I'm going to do is, at least for, well, I wonder if it makes sense for us to switch the asset importer and all the format stuff over first. And then come back and do this part. Because then we'll only have one entry through the asset system, and I won't have to refactor things twice. Maybe it makes more sense to do it that way. Okay, so if we look at the K-asset importer, and we'll go ahead and look at ASIMP. Right, so that's the importer from ASIMP. This already, I think, does every single thing that we actually need it to do for both static and animated geometry. So I actually don't think there's anything we have to do here. All we have to do is point to the K-asset importer. We have to point to the correct thing for that particular format, right? So we have this obj to KSM. Let's actually just search for obj. And we are going to, actually, I wonder if ASIMP automatically picks up the material files or not. That's going to be an interesting thing to see. So I think what we're going to do for now is we're going to say if we have an obj, we are going to take that and the MTL, and we're going to disable those. So I think I'm going to do that by commenting out all of this for now. We'll put a fix me in here. Fix me, remove this. Right, and actually I'm just going to take this and put it here, right? So that way our if statement can start off on a new line. So all we have to do here, I think, is just add. Actually, I'll take this one. Oops. And we'll paste it here. So we're going to just say obj. And I think that's pretty much all we have to do, right? The other thing is, one other small tweak that I wanted to make is we had this sort of concept of a KAM, which was Kohi animated mesh. But then we came up with the idea afterwards that, maybe we should just have a K3D, right? And so I actually want to rename this, and we're going to just say K3D, right? And we should probably maybe we should rename this to something, because we're not just going to handle DAE and FBXs, right? We're actually going to do, let's call this ASEMP to K3D, right? I think that makes a little bit more sense. And then we'll also have to put like eventually we'll probably just want to check an array of extensions instead of just having a bunch of these things, but for now that's fine. How come the renderer looks so much prettier than a year ago? Was it the castle and the ugly car themselves? Well, for one thing, we switched to PBR at some point. So that helped. And also we've made graphical updates along the way. I could import the Sponza in there if I wanted to. And it's okay, right? It's got a bunch of PBR materials as well. Yeah, we're gonna start at some point soon, probably making some assets just so that we've got some stuff to test with. 3-stream streak, appreciate that. Awesome. Very much appreciated that. Just gonna sleep and lurk? Yeah, fair enough. Fair enough. I appreciate the lurk, thank you. Okay, so we'll go up here to ASEMP to K3D, and we'll do KAsset model ASEMP import. So that's, we're gonna wanna keep that. And this is our importer for that. And so what we're going to do, in fact, I'm actually just going to close this other buffer just for a second, is I think we had KAM referenced a couple times in here. So this is going to be K3D. I'm just going to update all the comments and all that good stuff as well. Let's see, target path. So did we not have... Let's see, we have target path. Where did we actually build target path? That's built out and handed to us here. So import, from path. Let's see. We're not actually calling this anywhere. That would actually be pretty funny. This is what we're actually using, is import all from manifest. So it technically needed to be updated in both places. Let's see. And I think the manifest actually gives us... Yeah, here we go. There's another change here. So we need to comment out this guy and to there. And then also we're going to do the same thing here. And just change this to OBJ. Right? Let's see. Assets materials is where we're going to output the material names. And then let's see, asset path. So I guess the asset path we use directly from the manifest. So I suppose we should probably go and actually change that. I don't think any of our manifests actually use a static mesh right now except for the game one. So this is probably the only one that we're going to have to do. So any of these that are KAM, we're going to do K3D. And then also KSM is going to be the other deprecated type, right? So we've got a couple of those in here. And that should be it. Right, so everything's going to be K3D now. Okay, so I think that's actually all we need for that. We'll see. Also, this MTL. I don't know if I want to kill this one or not. Because theoretically it would be potentially useful to be able to import that still. Let me... should MTL be killed as well? Might be useful to import on its own. Right? Okay, so there's that. I'll keep that for now. Because we've done this, we're not going to hit that. So we'll see. Maybe I'll put a to-do in here. Just so I don't lose sight of it. Okay. So we import this. That takes the entire path. And I think as far as the importer and the converter goes, I think we should be good. So at that point, we actually, I think the only thing we might need to fix is the scene to eliminate the static mesh entity type and replace it with, replace it and the animated mesh type with the model type. So let's take a look at zone 00. We're gonna have to convert the other ones eventually to match this, but thank you for the sub over on the YouTube side. Appreciate that. Welcome. Let's see. How does import work on the usage side? Do you ask to import like a virtual file address? Yeah, so the way that it works right now is I actually have hooked up in here a import all assets from, right? And so there's one for the game itself, there's one for testbed, there's one for runtime, there's one for standard UI. This is the only one that has meshes. And what that does is, actually, if I go ahead and look in here in the config, I'll show you exactly what that does. So let's see, import all from manifest, right? So this is the game one. So what this does is this runs Kohi tools, and it passes the import manifest flag, right? So there's another one that would be import from file path if we wanted to do that. We've kind of scaffolded it, but we haven't really used it. Eventually we'll have to hook that up. And then it passes the address local to the workspace folder of the asset manifest. So it's essentially this same type of configuration for the other libraries too that include assets. So any of them that have a manifest, it'll basically just import that way. Eventually I need to write some shell scripts or something to do that where we don't have to rely on this to actually run it, but for now that's just kind of the way it is. So for now, essentially what it does is, let me make sure I'm on the right one. So for now, essentially what it does is it reads this file, which has both the source path, right? So the asset path is set by application config, right? So this is local to whatever that is. That could exist anywhere. And so that basically says, okay, well, here's the source path, right? And here's the path to the actual asset. So the way that it works is if this asset doesn't exist, then it goes ahead and says, okay, let's open up this file, import it, and write it out to this format, right? And that varies based off the type of whatever the source path is. Oh, you meant in the game code. Yeah, so the game code basically looks at assets kind of... Well, okay. You're talking game code or asset, or game code or engine code, I guess is the question. because most of that stuff is straight up in the engine. So when we configure a scene, for example, and we say I want to load, I don't know, a ground cube, right, which is just a static mesh. We have an asset here, which is test cube, and then we have a package name. So the package name tells us what asset manifest to look at, and then the test cube is basically the name of the asset. And from the asset system, the asset system reads the manifest for the appropriate package, says, okay, I need an asset named this. Where do I find it? And for debug builds, that is going to be a place on disk. And eventually we're going to have like binary blob kind of assets rolled up all into one huge file. And those will be going out with release builds, and it'll search that instead. Like in the game, when you play sound or spawn a zombie and put it there, do you put a job to prefetch them beforehand or stream it in when you request? I stream it in when it's requested. Yeah. I suppose we could prefetch it, right? If we knew, if we wanted to prefetch it for something like that, what we would probably do is include it in the scene like this. So that way, when we load the scene, we load that as well. That way there's an instance of it, right? And then we could just set it to hidden if we wanted to do that. So instead of spawning it, you would essentially load it ahead of time and just hide it, and then move it to wherever you want it to be, set it to state, all that stuff, and then show it. And that's if it matters whether or not, it spawns immediately. Generally speaking, none of this stuff takes more than a frame or two to load, so it's pretty quick. But yeah, we actually have stuff in the scene to, add entities to the scene, where we can pass the various properties for that entity as needed. Thank you for the follow. Appreciate that. Okay, so back to... Let's see, how many people here tonight were here Sunday? That was a party of 49 viewers on YouTube. Climax at the end with the animation success. Great day. Yeah, it was pretty good. It was nice to get the animation system running. For sure. Right, so we've got 6 static meshes in here, right? So we're just going to do, we're going to call them models now. And at this level, it does not matter whether they are animated or not. And that's sort of the entire goal, right? We don't care. Eventually what I want to do, and I can actually add this property now, is we eventually want to have, default animation name, right? And we can say, I think it's called hips for that one. And then we can do, something like autoplay equals true, right? These are going to be ignored for right now, but eventually that's the kind of stuff we're going to add, just to make it a little bit easier to configure. And then even timescale, right? We'll add lots of different properties to it. Okay, so we have that, and then we have animated mesh, which we have 2 of those, right? So that's just going to be, again, model. And there we go. So that's good. So our scene, at least from here, is updated, right? At least as far as the changes to the actual scene file. Now, obviously, we'll have to update Illumina scene. And for that, that's going to require, and this is one of the reasons I didn't want to do serialization yet, because I knew this was coming. So we have a bunch of places in here, first off, that say animated mesh, which we probably need to fix, right? So this is going to be, I'm going to just do model debug color. For that, I don't know why we're using white for that. We don't. Oh wait, it's not white. That's going to be teal. Teal. I suppose that's. I don't think we're using teal for anything else. Yeah, that's fine. Okay. Animated mesh states. So this one we can rename. This is going to be model state. All right, so that's gonna get rid of some of them. This is going to be model entity, and I'm going to rename this one to model entity, and it's not going to take, which is sweet. So let's actually just we'll do animated mesh entity, and we'll replace it with model entity. All right, so there's that, and then this is just going to be model specialized entity. We're going to get rid of static mesh entity, and I want this to actually break things. So we're going to get rid of that. Also, we do have an entity type in here. Go to the definition of that. So we have static mesh, and then we also had animated mesh out of here. So we're going to delete animated mesh, and we're going to go to static mesh, and we're going to change that to model. Now, the order of these doesn't really matter. Okay. So there's that. We should probably also take a look at this because that's going to break some stuff. So we'll do model, and then we'll eliminate that case. And we'll do model here. And then we've got one that's got to go the other way. So this is going to be model, and then eliminate that case. Okay. Let's actually go to the top, and we'll just kind of start picking through the errors, right? So we have a D array of static mesh type entities. These are going to go away, but I'm going to keep the mapping of these two separate for now. And then static geometry datas and static geometry extents. I'm going to, should I keep those separate as well? Just thinking. Yeah, I think I'm going to try and combine those. All right, so this is going to be model geometry datas. Actually, let me do a rename on that because that's, hopefully it works this time. Yes. And we'll rename this as well. So we'll do model geometry extents. And then what we're going to do is we're going to say, for this one, it's going to be transparent, animated model material map, right? And then this one's going to be animated model material map, right, for opaque. And then this one's going to be static model and transparent static model. Oops. All right. Okay. I think that's all we need out of there. So let's actually just take this and let's put it here. So they're all grouped together. Singy, how's it going? Good to see you. Welcome. Okay, so Map submesh geometries. Okay, so this whole thing. So the submesh index, entity index. This, yeah, I think we can actually get rid of all of these. In fact, I'm just going to do it. And this one. See ya. Oh, and static mesh loaded. We don't need that one anymore either. All right. So all of these can go bye-bye. And these ones we're going to do, we're going to say on model loaded. And we'll do model submesh geometries, map model entity geometries on map model. Okay, those were actually already named correctly. Perfect. Okay, so that's that. The other thing I did was I took all of the queuing and waiting on materials to load. I removed all of that from the scene. And material loads are now instant, right? So we actually, those are synchronous, I should say. So we don't jobify those anymore. And the reason for that is the material files are fairly simple. They're just basically a property bag. And we don't want to have to like wait for a callback just to be able to query its properties, like is it transparent or something. We want that instantly. So the material textures might not be loaded right away, but the material itself will be loaded and available right away. All right, so let's take a look at, this is our creation of scene, so we can actually remove those. And we're going to call this model entities. And didn't I didn't rename this. I thought I did. How did I do this? I guess just models. Sure. D-array of animated mesh model type entities. All right. So there we go. We have that. All right. So here, we actually have, let's see, static mesh. So this is actually the remove entity. And I don't actually know if we actually got to, did we ever get around to, I don't think we actually ever did add animated mesh to this. So we're just gonna, hijack this one. Model. And we're gonna do models. And models. And then model entity. Models again. And unmap. What do we do? Unmap model entity geometry. Wait, was that? Yeah. Okay. So that's, and then static mesh instance release. We want model instant, model, wait a minute. Static mesh system, static mesh instance release. Don't we have, okay, model instance release. I thought so. There we go. And then this is going to be model state. That's what we're going to use for that. So that's good. And then for the water plane, that gets a little bit weird because we do treat the water as static geometry. So we are going to have to change that to model. I don't know if there's going to be any fallout from that, so we'll have to see. That looks like the only issue with it, though. So hopefully that's fine. Okay, so add static mesh. So this whole bit, in fact, we're going to, let's see, add static mesh position rotation scale. Let's actually move this down here because I actually want to hijack that because we didn't actually have one for model. So we're going to just rename this to model. And this,
you dingus.
What is it? Add model entity? What was that? Oh, it's still called add animated mesh. Okay. This should be changed. So this should be add model. Right, so that should be add model. There we go. Thank you for the follow. Appreciate that. Do you use bind lists? No, I don't. It is not universally supported among older, especially among older GPUs, so I don't use it. Because I really don't want to have two different sets of logic to have to maintain. It's a pain in the butt. Binding isn't really that big of a deal. Let's see. Are you interested in making a settings file plus option menu? Setup resolution, FPS, shadow details, and so on. Sounds interesting. What are your thoughts? Yes, we're going to be doing that at some point for sure. Because we have a lot of the capability of setting that stuff now. We just don't have, you know, we're still scaffolding our game essentially, right? So we don't even really have a concept of screens yet. Or menus or any of that stuff. We got to build all that out. Which we will be doing on stream. So definitely stay tuned for that. Oops. All right. So this is add static mesh. So I basically just have to go through here and change things to say model. Model entity. And then model entity again. Models. And then this one's going to be model. Right. K static mesh instance is going to be K model instance. And then new ent mesh is going to be, instead of on static mesh loaded, it's going to be on model loaded. Wait. Yeah, we might have to change this too. Might make sense, right? I think I called it K model. There we go. And this needs to be model state. Right, so it's mostly just like converting stuff over like this and just eliminating the duplicate stuff for now. We are going to have to do, let's see, where do we push in here? We are going to have to do some work in here because actually it's going to be specifically in map model entity geometries, right? Because we need to make sure that these get pushed to those separate maps so that we can handle them separately. So entity type index, this probably needs to have one more thing added to it, which I'm going to say is B8 is animated. And we're just going to do that here. Is animated, right? And then when we go here, let's see, the instance. So we'll need to do the entity. Let's see, notify initial load complete. So the base entity, we're actually going to have to do, that's the instance. Oh, you know what? This is actually the wrong level to do that at. I just realized. We don't want it there. We're going to have to do that by geometry, because some of them can be animated, some of them cannot be. So we'll handle that when we get to it. Let's see. Animated mesh. So this is going to be model debug color. Okay. Next. All right. So this is deserialized entity, which is important. So we have one of each of these for animated mesh and static mesh. So I am actually going to take the animated mesh version, and we're going to replace that and use that for model. So we have model entity, there we go. Package name, right, and then add model. Perfect. Not too crazy there. This is get entity base, so obviously we need to change this to model, and then models subbase, and that's that. Thank you for the follow. Let's see. Been using glazed WM on Windows. It's been game changing, even if it was written in Rust. Basically i3 for Windows. Oh, that's interesting. I wonder how many applications that breaks in Windows. I don't want to boot into Windows enough to find out, though. All right. So there's that. Again, we have water plane. Okay, so this is where we add the water plane, right? So we want to treat this as static geometry. So we have static geometry datas. So we do want to add it to that.
You dingus.
Geometry array index. Okay, and then okay. So that's going to be model geometry datas. It's going to be the same here and here. Oops. And then model geometry extents. We're just going to treat those all as one now. And then we're going to do model geometry datas. And one more time here. All right. And that should actually, that should be fine as long as we handle the mapping correctly. Which I don't remember exactly how we do that, but we'll come back to that. All right, so this is going to be static geometry extents. This is going to be model geometry extents. Okay, and we don't have the ability to configure this at the moment, which is fine. We're not going to add that yet. We don't really need to. All right, so this is get static mesh render data. Now, this is one place where we need to maintain this split still. However, I'm going to rename these. So we still currently do have the requirement of these have to be rendered by separate pipelines. So we still have one pipeline for static mesh data and one pipeline for scanned mesh data, essentially is what we're calling it. And the only difference between those two is the vertex data, right? So eventually that is an item that we have to handle next. But for now, I think, the more I think about this though, like this function, and I think I think these two functions are basically identical. So I might be able to do some duplication elimination here. I think the only real difference is this. So we might be able to just extract this whole thing out to like a separate subfunction and then just pass a bool or something. This is just pulling from those different entities, which that's fine. They're all the same type of entity now, which that actually makes our life a little bit easier even. One more. There we go. Let's see. I think the only difference is this animation ID being set. Everything else I think is exactly the same. Yep. Okay. So what I'm going to do is, since this is ultimately the version we want, I'm going to take this, and for now, I'm just going to copy the whole dang thing. And I'm going to put it right above both of them. Right? And I'm going to make this static. And we're going to say get model render data. But I want to, yeah, we'll just go with get model render data. That makes sense. And then before the out material count, we're going to do B8 is animated. Okay. Right. And so what this is going to do is we'll come over here and we're going to do map, right? So we're going to say is animated, and we'll use that one. Otherwise, we'll use the scene transparent static, right? And then the same for this one, right? And realize this is a temporary hack until we get the other stuff straightened out. So scene opaque static model material map. There we go. Okay. So either way, we're going to get the proper thing. And then also, I think the only other difference was, if I recall correctly, was just this. So we can just say if is animated, then we do that, right? And so now what we can do is we can come back here. I'm just going to close this other buffer again. And so when we want to get static mesh render data, I'm actually going to rename this, and we're going to say get static model render data, right? Just to kind of stick with our theme there. And what this one's going to do is it's going to call Illumina scene get model render data, pass scene frame data, frustum flags is animated. In this case, is going to be false. If I can spell false. And then out material count, right? And then this is going to return that, right? And then that means that we can take all of this all the way down to the end of the function, right? And it just becomes that. And then this guy is going to be get animated model data, model render data rather, right? And so this is going to be the same thing. Only difference being is we flip this flag to true, right? And so once again, we're able to remove a whole bunch of stupid duplication, which is always a good thing. Perfect. All right, that cut down our number of errors quite a bit. Let's see. What plugin are you using for the rename pop-up? It's part of the LSP that I have, but the bot, if it wakes up, should give you a link to an article that I wrote that has all my NeoVim config. There it is. Everything's extremely snappy so far. Okay, that's good. Only semi-annoying thing is found is if I open WesTerm for the first time after I start Glaze WM, it hangs the application. But I've never had my terminal not open, so it's not been an issue for me. Interesting. Also, triggering WesTerm as a pre-open command for Glaze WM fixes that. Oh, interesting. Okay. Yeah, I can't switch away from WesTerm. It's really good. I like it a lot. Thank you for the follow, by the way. Appreciate that. Okay, so we've got that. Now, we have to do the get plain water data, right? Which is just going to be the model geometry datas. And that is the biggest part of the heavy lifting for this. The only other thing is going to be when we do a init-based entity. We should probably change this to be model. And then I think the only other thing that we need to do is in the mapping. So and I believe it was actually the geometry, the submesh geometry is what we wanted. Kitty cat. You guys want a free pet on stream? Oh, she just dug into my arm. Sweet. Yeah, let me change the camera here. Here's my kitty. She's none too enthused to be held. She hates being held, but she was handed to me just now, so. This pumpkin, she's 15 years old. She's baffling to me, but yeah, she wants to go. There you go. Ooh, a bleeder. Sweet. All right. Yeah, she's been wanting my attention all day for sure. Yeah, that's my kitty. She's a Japanese bobtail. Love her to pieces. Your cat tax. That's a good picture. I don't know if you want me to show it on stream or not, but I can if you want. You can show it? All right, cool. Yeah. Stupid ads. All right. That's a great picture. I want this life sometimes, you know? I mean, I like coding, don't get me wrong, but this is the life. Love it. All right. Looks like we just got raided. Patrick GH3, raiding with a party of 21. Thank you so much for the raid. Welcome, raiders. How's it going? What did you get up to on stream? Thank you so much for the raid. There's a shout out for you if you're not following Patrick. Let's go check out what did you get up to on stream. I'll go ahead and toss you a follow. Oh, I am already following you, actually. It said I wasn't for a second, but then it said I was. WebSocket programming for a Godot puzzle game. Awesome. That's pretty sweet. So WebSockets, I assume you're making a web-based game then. Well, let me break for just a second here and tell you guys what the heck we're doing. So What we're doing here on this stream, for those of you who are new, is we are making a game engine from scratch, written in C using Vulkan. It's cross-platform, so it's available on Windows, Linux, and Mac OS. It is very early in development. I say early. It's not production ready yet. And I'll get to that in a second. But Vulkan is our initial rendering backend. So I have support planned for Metal as well as Direct3D in the future. And the engine itself is free and open source. And so it is available on GitHub. I will drop a link to this website here. And so if you scroll down on that website, there's a GitHub link down there. And so the engine itself is Apache 2.0 license, which means you can use it for commercial or personal projects. Does not matter. All that I ask is that if you use it, you say you used it, and that's it, right? There will never be any sort of licensing or royalty fees of any kind ever. So the whole purpose of this is it's supposed to be an educational exercise on a way to build a game engine. It's not the only way to build a game engine. It's not even necessarily always the right way to build a game engine. We try a lot of different things on here. We experiment, lots of trial and error, do deep dives into what works, what doesn't. And, we just have a lot of fun just kind of messing around and experimenting with different features, right? So, yeah, that's essentially what we're doing. And then with this, the goal with this, the end goal, if there is an end to it, is essentially we are going to use this engine to then make a game and release that game on Steam. So the game itself is called Shadows of Illumina. You'll see references to Illumina here in the code. So that is the game code versus the engine code. So the game code itself will not be open source immediately, but lots of the templates that we're building are going to be based on this code. So those will be forthcoming somewhat kind of soon. I hope that makes sense. Please feel free to ask if you have any questions. And I really need a drink. Lots of talking sometimes just makes your mouth dry. Okay. Does Kohi work on embedded AMD GPUs? When you say embedded, do you mean like integrated? If that's the question, then yes. It'll work on anything that has Vulkan drivers, essentially. With a few caveats. Mobile devices, I don't quite have the setup to get that to work at the moment, but yeah, so like really, really old legacy hardware probably won't work, and then Vulkan on mobile probably won't work right now. I haven't even tried it, to be honest with you. But that's planned in the future as well. So yeah, but yeah, if you're just talking about like a laptop integrated GPU, then yeah, that does work. Okay. Yeah, from like, you're absolutely correct on that. Okay, well, anyways, so yeah, welcome Raiders. I do appreciate that. I also see that there's ads playing. So I'm going to repeat part of that in just a second, actually. So I don't know how many of you guys got caught by that. So it looks like there's like 10 seconds left on them. All right. So all right. So I just realized ads were playing, so I don't know how much of my intro got cut off. If you guys want me to do it again, feel free to say so in the chat. But yeah, I didn't realize ads were actually playing during that, so I'm not sure when it cut off. Let me know. There are no stupid questions around here. If you have a question about what we're doing, feel free to ask, right? As long as it's kind of related to what we're doing, that's cool. All right, so this is the last bit of sort of quote-unquote heavy lifting that we had to actually do as far as the submesh geometries are concerned. So what this essentially is doing is we have a combination of, actually, we have 4 different maps. So we actually have one for transparent animated models, one for opaque animated models, and then we have one for transparent static models and one for opaque static models. And eventually we're going to be probably combining those. Hopefully, I'd eventually like to have it all in one map, if I'm completely honest, but I don't know that we're going to be able to pull that off until we actually fix the shader issue. But what we need to do here is we're determining which map to use all the way at the top, right? Which we can't necessarily do anymore because we actually have to, let's see, we have to go through and figure out a free map index for, well, these two are fine. Let's see, model geometry data's actually I think this is probably going to be the one, annoyingly. So we're making the map determination here. We're probably going to have to move that down one because this get or create. Okay, so that's let me think about this for a second. So we get the correct list out of that map. So that would be the material list. So that actually should be fine. We don't actually have to modify that. Okay, so we have that. Let me just think here for a second. So we get the list from the appropriate. Okay, we're going to have to actually do this a few times then. Because where we really need to handle this is, let's see, we have the geometry, array index, and that's going to be, trying to think about how to do this without repeating myself a bunch of times.
You dingus.
So I guess we're going to actually have to look at the geometry, the incoming geometry, which is going to be this. We do have a geometry type. So I guess we could do, these are our different types of geometry, right? And right now, all we're actually using is this one and this one. So I suppose we could go with that. Okay, let's do this. B8 is animated equals, and then we'll say geometry type equals, what was it again? This one. I probably ought to think about reducing that set. So we're going to say if the type is 3D skinned, then it's animated, otherwise it's not, right? And so here we have transparent. So I suppose we should probably just split this out. So we'll do, I guess, is animated. We'll do as the first one. And then else, right? We'll take this and put it here. Oops. Right, and we're just going to zero that out and then do that. So if it's animated, we'll select from these two. If it's not animated, then we'll select from these two. So transparent, static, and opaque static. That way it gets it gets mapped to the correct place. I'm gonna put a to-do in this because this feels kind of dirty. Find a better way to classify this, right? Because technically speaking, well, I guess technically speaking, this description's wrong. So this should be skinned 3D geometry that doesn't change often, right? Versus dynamic would be something like you'd want to use that when you are like editing terrain or something. I don't think we're going to use that very much, to be completely honest. All right, so I think, is that it? Okay. Where is this? Aluminum main 1086. Oh. 1086, I think it was. So this is animated. Do we not have... What is it bleating about here? What is it? From int. Why is that int? Are we missing a include here? Get static. Oh, this should be get static. Whoops. Model render data. That's why. Okay. That's why. This should be animated model render data. This should be static model. So this is for all the different passes. So we've got a few places that reach into the scene and say, hey, give me this stuff. When we combine these in the shader, we'll be able to cut these in half, which will be pretty sweet. Let's see. I think that's actually all these are. I hate that it just goes, you know, hey, I don't know what this is, so I'm just going to assume it's an integer instead of actually telling you, like, hey, this thing hasn't been defined. It's super annoying. I know that's part of the C spec, but that's always annoyed me. Okay, so we have that. Now we actually need to go and run the importer, which is going to be interesting to see if that works, because we haven't tested that yet. So we're going to import everything from the Illumina manifest. So we'll run this. Cool. Non-zero size. Okay, so why are we... What have we done? Oh, you know what? I wasn't sure that the OBJ import was actually even going to work. That's not surprising. It doesn't like zeros. Oh, what a dingus. How did I miss that? Okay. So that's in the SMP importer. This one. And where was that again? That was like around 411. Okay, yeah, and I'll bet... Okay, we don't have anything there, so actually this what needs to happen here is if bone count then we want to do this stuff. We should, though, do that. Okay, so nodes. Let's see, is there a... So here's where we build the hierarchy via the node map. This is going to be the same thing. So we should do this. And then if node counts, then we want to do that. Thank you for the follow. Appreciate that. Let's see. Doesn't change often is probably like 90% use case, I'd imagine. Yes, exactly. Yeah. I would say it's like 98% use case. Because I'm not like doing morph targets or anything like that. Most of the stuff most of the animations I'm going to do are going to be all skinned animations. Does invoke some interesting ideas about shifting meshes. Yeah, and I think a lot of, like, any of that stuff that I would do anyways, I'd probably want to do in the shader. Like, if I wanted to have a tree swing or something like that, I'd probably do that in the shader versus actually, like, animating it out. Is Vulkan its own framework / language? But via C. So Vulkan is, yeah, Vulkan's like its own, it's one of many, or one of a few, I should say, graphics APIs. So it's essentially how you communicate with the GPU these days. So it's the successor to OpenGL, if you're familiar with that. Competitor to DirectX, competitor to Metal. Let's see. Tried building Kohi for my ThinkPad, but had difficulty. I'll give it another go. Yeah. It's also possible, like, bear in mind the engine is still not production ready, right? So if you have issues with it, I wouldn't totally be surprised. Feel free, though, to bring that up on the Discord server, and I or myself might see it, provide some error logs and stuff and the specific things that you're running into, and we might be able to figure it out. This version 0.11 that I'm working on now is going to have a lot of fixes in it, and so I'll be a lot more confident when that one goes out. All right, so let's see. We got node count here. Animations is going to be the same thing. We might not have any of those. So if out asset animation counts, and that needs to actually go all the way past all of that. And there we go. Theoretically, we can actually have one of these that does not contain any submeshes. And the use case there might be, like, maybe it only has dummy nodes that are inside of it that are animated for some reason, that we use for some sort of effect or something like that. That's, tied into within the game engine, but not actually containing geometry. And so our format supports it. The engine doesn't yet, but we are going to want that eventually. So here we're going to do out asset submesh counts, and then we'll just go to the bottom of this guy and close that off. Okay, let's build this and try that again. So let's go ahead and run. Okay, so we have an assertion in here for, right. Okay, I know what that problem is. This was because we were making an assumption there's always going to be animations, and there aren't always. So let's see, this is going to be right here. So vertex weights. So we only want to do this check on vertex weights if we actually have animations. Let's see, how can I check for that? So let's go to line 550. So this is what's causing it right here, right? So we basically need to say we only want to do this if we're animating something. Actually, we only want to do all of this if we're animating something. So let's see, extract submeshes, targets. Okay, so this is bones, right? So actually, I think we can actually just use this. Like if the mesh has bones, then we can do that check. Otherwise, don't bother. So let's see, bone data. We actually shouldn't even do this unless we have that, right? So we're going to do if mesh num bones, and then we want to wrap all of that logic in it, right? This we got away with because it technically zeroes itself out. It doesn't do anything, and that's fine. Let's see. Also, so there's a couple places where we did check for it down here, so we were smart about it there. This is in the middle of a loop, is it not? Yes, it is. So here we're going to actually have to say, we're not actually going to have access to bone data outside of this. We're going to have to hoist that up actually. So this is going to have to go, let's do this. Let's take this and put it here, and we'll set it to 0. Right? And then later on, we can just check to see if that thing exists. So we can say here, if bone data, then do that, right? Right, okay, that makes sense. Did my stream just cut out for a second? I saw both of them like refresh on the screen. Can you guys hear me okay? All good? Okay. Maybe it was just my machine flipping out or something. Okay. Let's see. Guess it's a framework for using the GPU. It's not really a framework though. So it's not really a library either. I mean, it is and it isn't. It's an API, right? It's a contract, right? So the way that Vulkan works is Vulkan is just an interface, right? It's literally saying you as the GPU have to implement all of these functions, right? And the GPU driver is what actually powers that, right? So it's up to NVIDIA and AMD and Intel or whoever is making the GPU. In their driver, they implement Vulkan, they implement OpenGL, they implement Direct3D, etc. For Mac, they implement Metal. And so it's more of an interface point than it is a library. But it does come with libraries in the form of validation layers that go with it. So technically speaking, it's kind of both. Did you get a chance to try Odin? It's pretty cool, simple language. No, I haven't had the time. I don't know when I'm going to be able to be completely honest, unless I do it as a complete side project. But Kohi takes all my spare time for sure. Familiar with it, but I haven't gotten around to digging in. If I ever do, some of the details still feel black box to me because of that. I guess OpenGL, yeah, OpenGL is a big black box. It's a huge state machine, right? Yeah. So, that they have to include it with the driver. Yeah, so the driver is the implementer. Yep. You'll miss macros in Odin. Oh, do they not have those? I use the crap out of macros. Odin has some things that make me not want to use it. That's why I chose Zig. Zig has some things that make me not want to use it. One of those being the syntax. But for me, I don't know. I'm just going to stick with C. C works. C does what I need it to. There's a couple things I miss from maybe C++, like operator overloads and things like that, but I've learned to live without them. Everything's a give and take, right? So, all right. So, let us try to run this again. Tried to free a null block of memory, but why though? Oh, during serialization. That's fun. Okay. Sure. I'm going to have to check all these. Perfect. Sweet. Okay. Well, like I said, model was making some assumptions. So, K assets, model, serializer. At least we're at the serialization, so we're past the import part, right? In theory. So this was 838. Okay. I'm really tempted to just wrap this in my macro. I think I'm going to do it. That way I don't have to do if all over the place, right? I could just do if block boom. Probably should have done that from the beginning. All right, let's try again. Okay, it looks like these offsets are good so far, so we're getting there. Channels data buffer. I did a K-free on that one, that's why. That's why that didn't get caught. So that's 861. Wait a minute. 861. Down here. Okay. If channels data buffer. So obviously if we don't have animations, we're not going to set up channels. Learned programming about 7 years ago using Python, never coded in C, but it wasn't that hard to pick it up after I learned the general programming concepts. Yeah, as long as you, like once you wrap your head around pointers, the rest is really easy. Okay, all right, so potential success here. We didn't get an error. So that's neat. I know that's erroring. That's been erroring for forever. I need to fix that at some point. Let's see. Okay, so test cube obj imported. Looks like it did the thing. And those are fairly small offsets. So I think we might be good. Let me go over here and look at. So there's going to be a couple of these materials that I want to revert. This is going to be one of them. Because I know that one's already correct from before. Also, I want to do, let's see, default material. That's a new one. Interesting. Okay. I don't know what that was part of. So test cube mat is going to be undone. And then this one, changed it to linear. So I'd like to keep, wait, yeah, linear is correct, but why did it change? I'm not sure why it changed those things. I might have to look at some of those properties. So I want to keep that. And then here's the K3Ds. So it looks like those are all in place. So that's good. And then that. Okay, so let's actually try. Let's see. Do I have to... I can't think of anything else I have to do. So let's actually just try and run it. Immediate poop. All right. Okay, allocate line. Oh, okay. So this might actually be... This might actually be query animations. Ah, I know why we're getting this too. Okay. That's interesting. And I'll go over that in just a second, but let's see. There is a bug in query animations. So if we are, if not count, oops, crap, return 0. Or actually, I'm going to start using knull. Okay, so that will fix the bug, but whoops, not K-scene, Illumina scene. We have a hack in here that says whenever a model's loaded, we try to play the first animation. And so we were querying animations. We does look like I went in here and I said, well, if we only want to do this if we actually have the animation count. Let me actually take these and move them inside here, because it only makes sense for animated meshes. Animated models. Have to change my way of thinking there. All right, so relaunch. Load. Huh, would you look at that? All of these are loading, but they are loading from our new model format, not the old one. So that's pretty sweet. Got that working. And just to prove that, well, actually, I mean, I guess I don't really need to prove it, but I can come in here and actually delete out of our assets. Let's see. Let's do Illumina assets, and we'll do models, which, see, we're already actually calling this models, which is actually kind of funny. So we have the KAM, so we can delete that. And really, it's going to reset. I can't stand this editor sometimes. Most times, that's why I don't really usually use it. Just, I guess, close down some of those other things. All right, so we'll get rid of the materials and models. We'll get rid of the KSMs, right? Those two guys. Right? And so our manifest is only looking at the K3D files anyway, which actually, this is actually giving me a hint that I need to update the gitignore. But if we take a look in here, Here's our 3K3Ds, right? So those imports worked, which was a heck of a lot easier than I thought it was going to be. I figured we'd run into more problems with it, but we really haven't, which is awesome. So I do need to add K3D to the gitignore, which is in here. I'm just going to do that here. Dot K3D. And I'll leave the old formats in there for a little while. Eventually we're going to wind up getting rid of that, but there we go. Let's see. It was about 6 months ago, trying to build it now and sorting through some issues. 6 months ago, you should be good. The Clang update problem is older. Yeah, that's true. Because we started off on Clang 12, 11 or 12, I want to say. And so there were some problems with like switching to newer versions, but okay, so I think I'm good with all of these changes so far. So the next thing I want to do is we are not using the static mesh system anymore. And so I want to remove all traces of it. So if we take a look over here, submodules, Kohi, and then we want runtime, and under systems, we have, let me just expand this a little bit. Actually, there's a couple things we need to remove. But the first thing is going to be the static mesh system. So down here, we're going to remove that and that, which is obviously going to cause problems with anything that's importing it. But, and then I want to go to asset system C. And do we have anything in here? Asset C and destroy nodes. Okay. Oh my, this is the, wait a minute, is this? Oh, this is all the legacy scene stuff that I still have to strip out from the core. Okay, I'm not going to worry about that for right now. Let's see, what is all this? So this is, that's all VFS stuff, so that's fine. I'm not worried about that right yet. Oh, static mesh serializer. That's another thing that can go. That's under what? That's under the core. So that actually can go bye-bye. So that's under core. Serializers, and then we have a few. Static mesh serializer. There we go. Delete. Yes. Delete. Yes. Okay. Let's take a look at what errors that gives. So static mesh assets, all of this. Actually, wait a minute. Before I do that, let me delete some of these types. Okay, asset types. That's what I thought. So we have the static mesh type here. Geometry, static mesh, all that. Okay. So now we can actually go back and delete that. Because now we just have models. Okay. What's the error that we're getting? Oh. All the stuff in the header file. Goodbye. Okay, so that's pretty nice. Now we just have models. No more static meshes and animated meshes. Now it's just models. I'm going to do a clear and rebuild. I know there's going to be some include errors and stuff that I still have to strip out. Oh yeah. Importer static mesh OBJ. That whole thing and everything it references can actually go. What was that again? Where was that? Kohi tools source importers. Okay. So let's see. Tools source importers. Serializers we might also need. Yes. There are some serializers. These guys, I think we might need to get rid of too. I was saying I might keep this one for MTL files, for material imports. I don't... You know what? No. I'm not going to keep it. So we have this. Right. Okay. And then I guess we should probably look at the importer again and see. So we'd have that one to get rid of. And we'll just clean again. Cassette importer. Oh, there was an error. Okay, so OBJ to KSM. Neither one of those things exists in the code base anymore. Goodbye. MTL to KMT. You know what? It's going bye-bye as well. I thought about keeping it. Not going to. Doesn't make sense. Don't need it. Okay, so we're going to remove all of this. And then there's another one down here. I thought, nope, I guess that one is the only one. Oh, here's the OBJ. And the MTL. Wait, does this function still exist? Why did we have that? Okay. Don't know why it was there twice. Okay. And wait, did that still exist? Oh, it did. Importers, material. Wait, what? Oh, yep. That needs to be deleted as well. Ah. Go away. I'm not sure what happened there. Okay. Now, that file doesn't exist. Okay, engine. Oh, that one's not surprising. I should have guessed that one. Right, so we already have the static mesh system in here. The K model system's right there. So what we have to do is strip this out. And let's see. Didn't we have in here somewhere? Animated mesh system. I had a feeling it was still called that. Model system. And let's rename this. Model system config. Okay. All right, so that's that. And then let's just also get rid of the shutdown for that, since that doesn't exist anymore. By the way, if you want some test assets, Kenny has some amazing prototype assets. That's a good idea, actually. That's a really good idea. I might snag some of those up. That's one of the reasons, by the way, that I'm keeping the game stuff private, is because I intend on using some test assets. And distribution rights on those things get really weird. Okay, Illuminacine has stuff. Might just be an include. All right, built. Let's actually, okay, I don't know why that opened that up. All right, let's hit the right dingus key here. Load this up. And as you can see, everything is loading up as we expect. Our meshes still have their different timescales, all that good stuff. I even put a light back here, although the test, some of the debug objects, or some of the debug geometry isn't following their thing correctly, so I'm going to have to figure that out. But that's a separate task for another day. I probably ought to adjust the fall off of this a little bit, because that's a little bit, I mean, it does. It's a little bit. It goes opaque a little bit too quickly, I think. Anyway, that's going to have to be adjusted per scene, I guess. Okay. Let's see. I guess still have these to do. Let's see. Do we have any? Static geometry data's array. Static position only. What is this? Oh. Okay, that's for the debug stuff. Okay, so that's fine. Raycast hit is fine. Static mesh load context. I don't even think that's used. Oh, I guess it is. Well, I'm going to delete it and also get rid of add static mesh, because it should just be add model now. So we can actually remove even more code. Oh, that was the reason the error was there. Perfect. I don't think that was being called anyway. Okay. Let's see. I think the only place that we should be using these is for like the static model versus animated model. I think. Oh, that was one other thing I wanted to test. Model debug color. When we do that, I think I want a different color if it's animated versus if it's not. We can get that from we have static mesh debug color. Let's do model static debug color, right? And we'll do model animated debug color. right? Different colors. And then we could just do let's see. Do we actually have I suppose we could just look through all of the submeshes and then figure out if any of them are animated, right? So B8 is animated equals false. And then we can do here if geo type equals kgeometry type 3D skinned. Then we'll do is animated equals true. And then here we could just do is animated entity model animated or entity model static debug color. That's a really long line. Let's split that up a little bit. There we go. Okay. Kenny is full open distro. You can put it in your GitHub repo. Put his license and link to his website anyway. Yeah, that's a good point. Yeah, I might have to actually start grabbing some of those because that would be good to actually like prototype a game with, I guess, if he's got, because I remember he's got like a ton of stuff. And even if it's not the free stuff, I could throw some money at it. Okay, so doesn't look like we have any errors. Let's check wireframe mode. Oh, interesting. They're still both the same color, which is not what I would expect. Why is that? Unless this is just not doing the thing correctly. Map geometries. Material instance. I guess in here, what do we do in here? Don't we do the same thing? Geometry get at. Oh. I just realized this is being done twice, which is bad. But we're literally looking at the same thing. Geotype. Submesh index. Right? It's like literally almost the same. Sure. Okay, I can do this. But like that's literally should be the same thing. Actually, it's not the same thing. Because I only want to change it if it's true. Why would that work in here? Mat instance. Submesh index. So if any of them are, yeah, that's weird. Unless so that's 0111 and that's 0101. That should be create debug data. Unless I'm doing something stupid in here, which is possible. Let's see. Data color is color. Why do I have an out color? What is that? Wait, what? U32. Oh, I just have it named funky. Am I... So we have size, then transform, then the type, then the color, and then the badly named thing, which should be debug data index. Oops. Yeah, it's named badly here too. Now to debug data index. Oh wow, does that even actually get set? Oh, that might be the problem. Yeah, okay. We never even set it. I think I understand why that's happening now. Probably why we're getting some weird issues with debug data in general. Cool. So the index is going to be what we're going to use. So we're essentially going to do out debug data index equals index. I guess we must have been defaulting it to 0. Or I guess it would default to 0. Okay. I wonder what this is going to like fix and or break simultaneously. Well, some of the bounding boxes look better, for one thing. So that's neat. But it's still using the wrong color for these guys. We are setting the data color up. Render geometry upload. Data geometry. Oh, are we? Wait a minute. What are the odds? When we do the query for that, what are the odds that we're just like not using the right color? Let's see. That's the BVH AABBs. That's fine. No, it should be using data color. And the fact that this is working. These are all different. I don't understand what I'm missing. Maguettes, how's it going? Some kind soul has gifted you a sub. Completely missed it. Yes, that was probably on the Sunday stream. A kind soul came in and dropped 20 subs. Have you seen the tech demo video about Project Shadowglass? I have not. Curious how the dev pulled that exact graphical look off, because it's 3D FPS, but it looks like pixel art. Not convinced that it's all voxelized, or there's something smart going on behind the curtains. Interesting. What I will do is I'll pull that up in another tab and look at it off stream. Let's see. Andre de Santa Cruz, how's it going? Welcome. Where do you draw the line between a mesh and a model? So that definition has changed as of this stream. So a model encapsulates multiple submeshes, right? So the submesh is actually what contains both geometry and a reference to a material. And so that's the definition of a mesh. And then a model encapsulates one or more of those things. But a model can also contain other data like hierarchical nodes, bones, animation data, that kind of thing. That's the real difference. Okay. Yeah, I'm really not... I think the only thing I'm going to be able to do here is, I guess I'm going to have to step through this in debugger, as stupid as that is. So Illumina Scene 1860. 1860. So let's actually do wait a minute, I'm dumb. This is for the debug data, not the actual mesh being rendered in that. Jeez. Okay. What a dongus. Okay. I was confusing it. The debug data would be like the shape that goes around it, right? Versus the actual mesh geometry, which is what I was really wanting to change the color of. And I just mixed it up in my head. So that's actually going to be up to the renderer. Which means these, I guess, don't really make sense, but oh, you know what? I think that might actually be hard-coded in the shader at the moment. Because we have render mode. And render mode 4. Here's the answer. It is hard-coded in the shader. So what I really want is to know at this point whether or not it's animated or not. So I guess there's an easy enough way to do that. And we can actually do all of it without even touching the C code. What we can do is on our DTL, or data transfer object, from one side to the other, we have, let's see. Oh wait, that's the immediate data. I want this, the DTO. We have padding. So what we can do is we can literally just take one of those things and say uint geotype, right? And we'll do 0 equals static, 1 equals animated. And then I'm going to take all of this and go into the vertex shaders. Let's see, here we go. And just paste this here. And go into the non-skinned one. And again, go to the DTO, do that. And then the difference would be in main, since this is the non-skinned one, we're going to do out DTO geotype equals 0. And then I'll take this line and go into, let's see, the skinned one. Do the same thing, except change that to 1. Right? And then go back again to the fragment shader. And we have geotype. So we can do render mode equals 4. Right? And this isn't great for performance, right? I'm going to have another branch in here, but this is debug stuff, right? I'll remove this. I'll remove this long before we release with it, right? It just kind of gives me another tool to work with. So if geotype equals 1, well, actually, I suppose we should do 0 first, right? Since that's the case that we already have there. And I'm going to do an else if geotype equals 1, and then another else, or just an else, right? And this up. And for this one, I'm just going to copy this. And for this one, I'm going to do, instead of cyan, for animated ones, I guess I'll do magenta. Good enough, right? And then what I'm going to do here is if we don't have a valid type, I'm just going to do straight up red. What are you doing, you dingus? All right. So now oops. Undeclared identifier. Oh. I didn't do in DTO dot. That's why. Okay. That should work. Right, so we do that.
You dingus.
Dingus indeed. Oh my god, it's still wrong. How is that possible? What am I missing? Like, those are actually different colors. What? This is the only place it's checking for render mode 4. I'm literally setting it to 1 there. Well, help me understand this. I don't know. Not a huge deal, but I'm going to put a pin in it for tonight. It's probably something stupid. I'll finish it up off camera. All right. Yes, it was Footlong Icicle. Yes. Couldn't remember the name. I suppose I could look that up in history, maybe. I don't know if it shows up or not. Okay. So, I'm going to find somebody to raid. And while I do that, I just want to say a big thank you to all you guys who have joined me here. I really appreciate you guys being here. And we've made some really strong progress over the last few days, for sure. The last couple streams, anyway. But yeah, I want to thank you guys for being here. If you haven't already, I would greatly appreciate a follow. All right. Actually, Spiro's streaming, so we're going to go see what he's up to. Well, I'm going to raid and run. You guys are going to see what he's up to. But, yeah, we're going to raid Spiro. Anyways, guys, thank you so much for being here. And I will see you in the next stream. See ya.